Okay, in this video, we're going to focus on the chapter of surds, focusing on two skills. Firstly, how to add, subtract, and multiply surds, and secondly, how to rationalize the denominator of a fraction with surds. So let's start with the first skill, adding, subtracting, and multiplying surds. Let's look at example 1. Let's say I have this expression here, root 3 plus 2 root 3 minus 5 root 3. So how do I add and subtract these surds together? So how to see this, that we can replace this surd root 3 as x, for example. In sec 2, 1 and sec 2, we have learned that if I have an x term here, and these are all like terms, x, 2x, and minus 5x, I can simply add up these terms by adding the coefficients together. So this will be simply 1 plus 2 minus 5. And therefore, to simplify this would be simply negative 2x. So similarly, in this case over here, we can see surds. We can just replace the root 3 as x, for example. And in this case, to simplify this expression, this is simply negative 2 root 3. Okay, and this is how we add, simplify, or add or subtract surds, as long as the surds are the same. So over here, we can only add them together because these are all root 3. But if I have, let's say, another term, let's say root 5, for example, I cannot add surds that are root 3 and root 5 together because they are unlike terms, and we can only add surds that have the same surd form, let's say root 3 plus 2 root 3 together. So in this case, for this question, this is how we add or subtract surds. For example 2, let's say now I need to multiply surds. 2 root 5 times 3 root 5. So if to calculate this, we can go back to the property of surds which we have learned before, which is that for any real numbers, a and b greater than 0, root a times root b gives us root ab. Okay, and root a times root a gives us a. So for this question, an easier way to see this, if to break this down very explicitly, this can be seen as 2 times root 5 times 3 times root 5. And we can rearrange these terms to become 2 times 3 times root 5 times root 5. And from here, we will simply get 6. And root 5 times root 5 gives us 5. And therefore, my final answer to this question will be simply 30. Okay. So this is how to add, subtract, or multiply surds together. Moving on to the next part, rationalize. Rationalize means to remove surds from the denominator of a fraction. So let's say for this example 3, 1 over root 2, to remove the surd from the denominator, simply I just need to multiply root 2, because we know that root 2 times root 2 is equals to 2. The surd will be gone. But in order to do that, I need to multiply root 2 over 2, which is equal to 1. So the reason why we can do this is because this is equal to 1. But I'm multiplying this so that I can remove the surd from the denominator. So in this case over here, numerator times numerator, this will be root 2 over denominator times denominator. This will be root 2 times root 2, which will give us 2. Okay. And for the last example, example 4, let's say I want to get rid of the surd. Root 5 from this denominator over here, I need to make use of a special property, which is what you have learned in lower sec. A plus b times a minus b gives us a squared minus b squared. So what I can multiply to this fraction here is simply I multiply this by root 5 minus 3 over root 5 minus 3. Okay, it's important to make sure that this fraction is equal to 1. Okay. Then what I will notice is that from here I can simply simplify this. Numerator will be 2 times root 5 minus 3. Whereas for my denominator, it will be this is a plus b times a minus b. So I'll get a squared minus b squared, which is root 5 squared minus 3 squared. And I simplify this, I'll get 2 root 5 minus 6 over 5 minus 9. Simplify this further, this will be 2 root 5 minus 6 over negative 4. This can be simplified into 3 plus negative 3 plus root 5 over 2. And this will be my final answer to this example. So I hope that through this video you are clear on these two skills, how to add, subtract and multiply surds, and how to rationalize the denominator of a fraction with surds.